All right, today is 2.2, and it's polynomial inequalities. So for 1 and 2, it says you want to use the graph to solve the inequality. And what I want you to notice is this says x squared minus x minus 12, which is this parabola. Where is it positive? So I'm using a highlighter here, and where the graph is positive is above the x-axis. So that's negative infinity to negative 3. It doesn't say equal to. Union 4 to infinity. All right. We're going to do a similar situation. If I go to y is 12, okay? And so this side is the x squared minus x, and the other side is 12. So where is the parabola below y equals 12? Now notice it has the or equal to. So it's negative 2, comma 4. Whoops, wait a minute. I just caught that. Isn't that 1, 2, 3? Negative 3, sorry. That is negative 3. Do you notice that I could have subtracted the 12 and then looked at where, if I had shifted the graph down like this, that would have been shifting down 12. So it says, how could you use the graph in number 1? This one's the graph of x squared minus x minus 12. And you could have looked, if I use a new color, do you see it would have been this region right here? All right, so to solve a polynomial inequality algebraically, what you're going to do is you're going to set one side equal to 0. So if I have x squared minus x, I subtract 12. Step 2, find all the zeros. So that means factor completely. Okay, you need to factor completely. So that's x minus 4, x plus 3. So my zeros are x is 4 and x is negative 3. Then I'm going to use a sign chart. Okay, this is going to be a sign chart. If you have the or equal to, those are closed circles because at those x values, the left side is equal to 0. Then what I do is I use this factored form and I pick a test point. So if I try, let's say x is negative 4. I'm going to plug that in, negative 4 minus 4, negative 4 plus 3. That's a negative 8 times a negative 1. That is positive, okay? That is positive. Now, what if I pick x is 0? So I get 0 minus 4, 0 plus 3. That's negative 12. Then let's pick a number here, which is 5. 5 minus 4, 5 plus 3. That's a positive. So a less than or equal to 0 is 0 or negatives. So my solution then is negative 3 to 4. Okay? So it just takes a little bit of getting the hang of it. So number 2, I'm going to subtract the 8x squared. And now you're going to factor. So you want to start with your GCF. Okay, so I had a GCF of x squared. And now I'm going to factor that. It does factor into x minus 2, x plus 4, greater than or equal to 0. So my zeros are 0, 2/3, and negative 4. So I have an or equal to, so these are filled in circles. Okay, these are or equal to. And then all you're doing is, so let's pick -5. Okay, I'm picking -5. So -5 squared, 3 times -5 minus 2, -5 plus 4. So what I do is I'm like, that's a positive times a negative times a negative. So that's positive. I don't really care what the numbers are. I care whether my output is positive or negative. So let's try -1. So that's -1 squared. And in case I lost you, I'm plugging right here into this one. Then that's -3 minus 2, -1 plus 4. So do you understand the x squared is always positive except when x is 0? That's a negative and that's a positive. So that's a negative. So then this next one's hard to do because from 0 to 2/3, you might pick 1/3. I got a negative and then a positive. So I'm looking for greater than or equal to 0. So those are 0 or positives. So that's -infinity to -4. That's a bracket. Union. Now, do you see 0? So this is like going to look weird. We're going to use this funny brace. I need to include 0 because that, when I plug it in, gives me an output of 0. And then 2/3 to infinity. All right, so in the next example, so this one is already set up where I can read the zeros. So the zeros are -4, 5/3, and 6. So I'm going to make a number line. So these are closed circles. And again, you're going to do your test point. Because I've already done that, and for time's sake, this is a minus, minus, plus, minus. So I'm looking for the minuses and 0. So that's -infinity to 5/3 with a bracket, union 6 to infinity. All right, then what about this one? I need to refresh your memory. The inside of a log must be greater than 0, okay? That's a refresher from Algebra 2. So x squared minus 5x plus 6 must be strictly greater than 0. So this factors into x minus 3, x minus 2. So my zeros are x is 3 and x is 2. Now this time, do you see it's not equal to? So I've got to put open circles. And let me go through because I didn't do it on the last one. So let's suppose I pick x is 0. And I'm plugging in here. I think the factored form is the easiest. So you have 0 minus 3 times 0 minus 2. That's a negative times a negative, which is positive. Now let's pick, say, 2.5. So 2.5 minus 3, 2.5 minus 2. That's a negative times a positive, which is negative. Then let's pick, say, x is 4. So I get 4 minus 3, 4 minus 2. A positive times a positive is a positive. So the domain then is everywhere I see the plus. These circles are open, so it's -infinity to 2 with a parenthesis, union 3 to infinity. All right, there you go.